Hello everybody, welcome to my class. Today I am going to discuss about integration by part method, that is also called integrations of product functions. That is the product of the functions, you can say, which is y equals to in the form of u times b, where you can say u is a function of x and also b is a function of x. So both we are talking of the functions of x, but there are two different functions. Alright, so popularly known formula for this methods are, you can see this is the first formula and this is the second formula, and these two formula do not give the different result. These are in fact the same formulae. Alright, but we have these two formulae in two forms, so we'll discuss about the both. And so first of all, let's see that you are given, so I'm talking of one. For example, if you are given y equals to any function like u times b, for example, it's here, alright, and you'd like to integrate this function. So first of all, what you can do actually that, because we require to take derivative of this function, so it is dy by dx equals to, you can say it is u dv by dx plus v du by dx. Alright, so here we used product rule, and then after that you have it is d in place of y, you can put here uv dx, and then it is u dv by dx plus v du by dx. Alright, now as we are going to develop the formula to integrate the given function y equal to ub, so what you can do in this case is that you can integrate both sides. So here we integrate this sort of thing from both sides dx, and then this is again dx. Alright, and after this step we can see that yes, so what you can see here is that as the derivative of the function u times b, this is u times b is dub by dx, then antiderivative, that means the integration is just opposite of the derivative, is only ub. So what you can write after that, this is going to be u times b equals to, now expand this, distribute this in sign of integration inside. So what we have here, this is u dv by dx, and then it is dx. Alright, and in between the sign there is plus sign, so you can write here times plus integration v du by dx, and then this is dx. Okay, so after that what you can see here is that you have to transpose one of this sign of integration. So what I am doing here is that if I keep to the right side the integration of u dv by dx, for example, and then dx, alright, and then in the left side you will have this is u times b, and if you transpose to the left side, then if you put this in everything in the right side, then it is going to be minus v du by dx and dx. Alright, so we have got this first formula, which is called the integration by part formula, and also the integrations of the product functions. Alright, so let's see an example where it is applicable. So I will take the general example, simple example like we can do by direct method also. So here what I am taking here is that I am interested to find at this time the integration of x plus 1 and x minus 1 in order to explain the application of this formula, and later I will tell you that why this formula. Okay, so here in this case you can suppose if you compare these two, Okay, if you compare these two sort of thing from the left side, so what you can say, x plus 1 as u, so you can write here u equal to x plus 1. Okay, and in place of x minus 1, this is dv by dx, so you can write here dv by dx equals to d by dx equals to x minus 1. And now, as we are going to find the integration of this function, you have to check right side what we require. So we require u, so we have already the value u available, and also require v, so you have to get v from here. So v from here means you can take this way from here. So how do you get v? By integrating both sides. All right, so when you integrate this function from both sides, so it is dv by dx and then dx, all right, equals to integration of x minus 1 dx. And now you see that derivative of v is dv by dx, then definitely the antiderivative is going to be v. So we have the value of v, and towards the right side, this is x squared by 2, integration of x is, and integration of 1 is x, and usually you put constant term. So at this time we don't require it, we'll put the constant at last. Okay, so we have got the value of v also, and then what we require now, we require value of du by dx also. So we have u available here. So from this u, what you can do, you can find derivative of this du by dx. We will look at the formula, that what we need, and then the derivative of x is 1 and the derivative of 1 is 0. So in fact the derivative du by dx is going to be 1. And now proceed further. Okay, so if you proceed further, and then you have the integration, therefore we can also write I equals to x plus 1 x minus 1 dx. And at this time we are using formula 1, that means we are using this formula. Otherwise you can write it here if you feel it is comfortable to you or easy to you, but I am just taking the reference of this formula in order to write the integration term. Okay, so u means we have here in this formula u is x plus 1, so I write here, or if you like, just you write the formula again, uv minus sign of integration v du by dx, and then whole dx. Okay, so u means we have x plus 1, that is x plus 1, and v we have already seen here, this is x squared by 2 minus x. So we put the terms for u and v both, minus now v is again here x squared by 2 minus x. All right, and for du by dx, we have here just seen it is 1, so we put here 1, and then this is dx, and finally we have what we have actually. We can multiply this 2, or yes, here we can keep on working, so it is x cubed by 2, and now here you have now only the integration of this sort of things are left here, so put into the bracket because there is negative sign, so it is x cubed by 3, so it is 1 by 2 is over here, so integration of x squared is x cubed by 3, and then minus this is x squared by 2, integration of x is x squared by 2, and finally we put constant c. And after this step, let me go here. So now we open this bracket, so this is x cubed by 2, so this is x cubed by 2 in fact, and then this is minus x squared, and plus x squared by 2 is going to be minus x squared by 2. All right, and then x is remained here minus x, so write here minus x, and now in the another term we see that it is inside the bracket, and just in front of that is negative sign, so it is minus x cubed by 3 times 2 is 6, so this is x cubed by 6, and minus times minus is plus, it is x squared by 2, and then this is plus c. You can see that minus x squared by 2 and plus x squared by 2, they got cancelled out. And finally we have x cubed by 2 as the denominator is 6. So what you can write here, 3 x cubed by 6 minus it is 1 x cubed by 2. You can see yes, minus 1 x cubed by 6, and then lastly it is constant term. Just take the LCM, or otherwise just we can say that this is 3 minus 1. Now as the denominator are same here, so we have it is 2 x cubed by 6 minus, yes, we are missing one term over here, so negative, this is minus x is remained here, so you can put here minus x, and then after that this is plus, so it is 2x cubed by 6, and then minus this is x and plus c. So minus x is remained here, and then this is c. So finally it is x cubed by 3 minus, you can see here this is x, so this is x and plus c, and this is the answer. And let's check it directly also whether or not this is possible. So from here, if you keep that directly, then you can see here, if you expand from here directly, then it is going to be, it is in the form of a plus b, a minus b. So it is a plus b into a minus b. All of you know that algebraically this is a square minus b square. So you write here x square minus 1 square is itself 1 and dx, and then it is integration of x square is x cubed by 3, and integration of 1 is x, so this is minus x, and then lastly we have constant. And you see that by using the both method, okay, we have got the same answers. That means the method that we are dealing through is correct. Alright, so that was only the objective. But what happens usually, why we use this sort of function is that, for example, instead of you will have instead of this sort of simple function, for example, where you can multiply them easily. But for example, suppose that it is given as a square root of this, and its power is given as, for example, 1 by 5. What sort of difficulty will arise? You can see that it is the root, so if you expand it, it requires the use of binomial expansion, and here also it requires the binomial expansion, and that will be very clumsy process, lengthy process, and also sometimes this is not possible to make this sort of function in the integrable form like we did over here. Therefore, this is important to go through the method of product rule in integration. So this is the main objective. And also, if there are some functions which cannot be multiplied to the integrable form, in those sorts of cases also the integration by part is important. So let me take one example. So I am taking one example of like I equals to log x. So all of you know that the derivative of log x is 1 by x, but we don't know the antiderivative of log x. So while finding the antiderivative of log x, this sort of formula is applicable. So we have to now we can write another step like this is 1 times of log x, you can write, and dx. And here you have to decide, it is 1 is also a function of x. For example, if you write fx, that is 1, that means x to the power 0. So also you can suppose 1 as the function of x. Okay, but the difficulty arises in order to arrange them, whether 1 should be first or log x should be first. It's okay. So that is up to our working. Okay, so for example, 1 time of log x doesn't work, then we have to try through the log x times 1. So let's see whether or not we come across the integration of this log x by using 1 at the place of u. So this is at the place of u, and this is log x at the place of dv by dx. What can you think of what happens it is? If you find du by dx as it is required here, it's going to be 0, maybe term will vanish. And if you put this dv by dx log x, then what happens? It will be 1 by x. Okay, so good idea is that you see here du by dx, so we put log x in place of u and 1 in place of v. So let's check that way. So in this way, what I'm going to do is, now I'm taking log x times 1 dx, and in place of log x, I will suppose that as u. So this as u, 1 as dv by dx. Okay. So here, let's suppose u equals to log x and dv by dx equals to 1. Okay. And let's see in this formula towards the right side, you require u. So we already have u equal to log x, and then we also require v over here. So how do we get v? Just by integrating this. So integrate both sides with respect to x, and then this is going to be 1 dx, and here after that derivative of v is dv by dx. That means the antiderivative is v, and the integration of 1 is x, so v equal to x. And also we require what we need actually, we need du by dx term also. If you use this formula in order to find the integration of log x, so that from here you can get that du by dx equals to d log x by dx, and this is 1 by x. So we have all the values available here. So therefore we can write I equals to integration of log x dx, and go to the right side. Here you can see this is u times v. So value of u, you can see here is that log x, and value of v, you can see that it is here v is x, and minus, then go to the formula again. There is the sign of integration. Now we put v, in place of v you can put x. So we have here x, and then du by dx. Just now we have seen it is 1 by x. This is 1 by x. So this is up to you, that how do you make your work easy and integrable. So we put all these value of v as x and value of du by dx as 1 by x, and now finally according to the formula there is dx. So I write here dx, and then x and x having cancel out. So and then yes, equals to, it is, you can also write it is x log x. Log x, if I don't write the base, that means it is the base e, or also you can say this is ln. Okay. So this integration of 1 dx, and so it is x log x minus 1 dx. So the integration of 1 is, you know that this is x, and finally you put constant, and this is the answer. So this way we can apply the integration by part method to integrate the given function. Next, let's see the second form of the integration by part formula over here. So in this case, first of all, I take the first another variable, let y equals to uw instead of uv. Later on we'll work with the variable v also. So I am taking here w, because but we require in term of v, for example. So again we do the same process, like it is dy by dx is going to be, it is yes, you apply the product rule. So it is u times dw by dx plus w times du by dx. Okay, and we'll do the same process of integration from here. So if you integrate from both the sides, okay, everything should be integrated with respect to x, that we did just now. This is dx, and after that you can see that this is integration of dy, means we have uw at this time, and then this is by dx equals to, it is u dw by dx, then dx plus w and du by dx and dx. Now keep this term to the right side and everything towards the left side then. So what happens after this, algebraically I can get here u dw by dx and whole dx. You can keep into bracket also if you like. Okay, and then towards the right side, what happens, it is it is the sign of, yes, it is, yeah, so d and d, this is the derivative of uw. So if you integrate that with respect to the same dx, then this sort of thing is going to be uw. All right, and if you transpose to the right, it's going to be, no, it remains here uw, and whole thing if you transpose to the left and then you write everything to the right side, it's going to be minus w du by dx and this whole dx. All right, now next, let's suppose that, okay, again you can say dw by dx is going to be what, v, for example. Okay, we are talking for this sort of thing only, and we are interested to find w at this point. So it is, you have to integrate both sides. So this is dw by dx, integrate both sides with respect to x. So it is going to be integration of v dx, and as the derivative of w is dw by dx, so its antiderivative is definitely, it is going to be w. Okay, and then it is going to be v dx. So what you can do actually, that you can replace in this sort of term dw by dx by v, and in place of w you can put back integration of v, and you know that v is, again, this is a function of x. Both u and v are functions of x. This is fx. So let's continue after that. So after this, if you continue, you are going to have, it is u, in place of w we have v, and then this is dx. So you can see here, and then in place of u we have u, and in place of w, what we have got just now, in place of w you can see here we have got just now it as v dx. In place of w you can write here v dx, and there is the term minus, so you can write here minus, and then again in place of w, so what you can write here, so du by dx first of all, and then in the and for w you can write, so du, so integration of whole thing is going to be here, and in place of w you can write here again v dx, and then close this bracket, and this is dx. So this is the another form of formula to find the antiderivative of the given function by part method, or integration by the product methods. Okay, and let's apply the same formula to the examples we have done just now. So I'm using this sort of formula in order to find, this is log x dx, and let's see whether or not we get the same answer as it was x log x. Yes, it was, if you remember, it was x log x minus x, so this should be the answer, and we got this through the previous form of the formula. So here we will do the same thing here. It is yes, so it is log x times, you can say it is 1 dx. Okay, you suppose u as log x as u and log x as v, and you know that ub, this is you require the skill or effort, I will say, whether to put log x as u or v. Okay, it depends. So just if I'm applying this formula, so you can say that this is in place of log x, you can say in place of u there is log x, in place of v there is 1, I have supposed here. If it don't work, we have to flip, and then in place of u you can write here log x, and then in place of v we have 1, so 1 dx, and minus in place of sign of integration, and in place of d by dx here it is u, so u means it is again here we have log x. All right, and times it is integration of v means we have 1 again, you can see in this formula, and this v also, so it is 1 dx, and then it is whole dx. Okay, and after this step we have, it is log x, we have to do nothing for log x, then times integration of 1 is x, and minus inside the bracket we work for, so derivative of log x, you know that this is 1 by x, and inside the bracket again the antiderivative, here derivative of log x, here we have to do nothing, but here we have to integrate 1, so integration of 1 is x, and then still the integration is remained here, and it is now x log x minus, we'll have now this term, these two terms cancel, so this is integration of only one is there, so dx, and finally it is x log x. Okay, so minus in place derivative integration of one is x, and finally it is constant c. So this way we can prove and also apply the formula where the integration by part is applicable. Okay, so this is all about this topic, integration by part method. Okay, so okay guys, hope this is clear to you all. If any of you still have any doubt, you may ask me question in the comment box. I'll try my every best to get you back as soon as possible. So this is all for now. Take care and thank you for your patience.